14? No, 20.
Number 20. 732.
732? Yeah. No.
Oh.
No. That's 2.7.4. Yeah. I know.
Because that one's with our dividing rational expressions.
This is 7.3.2.
Well, you must have circled the wrong thing then. Like the wrong question.
Because which problem are we on? Because those are the same one.
Oh, this is never mind. So
7.1 or 7.4.
7 point hers.
Okay.
And
Okay, you need to get this together.
real. Where'd it go? Where is it?
What happened?
What in the world?
I think they might be sick.
They're siblings.
They are?
Yep.
I see that one.
Yep. Where did it go? Hope I didn't. She told us.
Well, you know where Manuel lives.
Okay.
I wonder if I threw it away.
We can come back to it.
What can we do? 2.4 or 7.4?
Okay.
And then 20.
Number 20.
20, yeah.
Number 20. All right, number 20. For us to be able to add or subtract, we need the denominators to be the same. Now with 3 and 4, we need to figure out what's the first number that'll turn with least common denominator to make them be the same. Well, the first number is 12. So with our 4, we would need to multiply it by 3, and the 3 we would need to multiply by 4. X squared and x, well, our least common denominator would be x squared. We need to get to be x squared. So to turn 4x into 12x squared, we need to multiply it by 3x. To get 3x squared to be 12x, we need to just multiply it by 4.
Find the least common denominator.
It's really the first number that's going to make them be the same. Now we can break it up into the prime factors. Well, 3 is just 3. 4 is 2 times 2, or 2 squared. Now we take the most of each number. For 2, we would have 2 squared. And 3, we'd have 3. So for this here, it works out that 4 times 3 is the least common denominator. And with x squared and x, it's going to be x squared because we're moving up. Now at this point here, we're going to multiply. 4 times 8 is 32. 4 times 3x squared is 12x squared. Here, 5 times 3x is 15x. 4x times 3x is 12x squared. Now we can add these two together. Since the denominators are the same, we can add the numerators. So we have 32 plus 15x over 12x squared. So we have this. You're welcome. Any other questions on the homework before we move on to the notes? Yes. Which one are we looking at next? Be nice, guys. 20 what?
Or 14.
14.
Stop. Be nice.
Now, before we can find the least common denominator or least common multiple for this here, we do need to factor both of these.
This one is not cardinal, sir.
Now, 9x squared minus 16, this is a difference of perfect squares, which would be 3x plus 4 and 3x minus 4. Now, our 3x squared plus x minus 4, since the third term is negative, our signs are opposite. Factors of 3x squared, well, we would have x and x, 3 and 1. Now, our factors of 4 are 1 and 4 or 2 and 2. Now, we can check this here to make sure. 3x times negative 2 is negative 6x. 2 times x is plus 2x, giving us negative 4x. So that's not the middle term we wanted. Now we can't switch the 2 and 2, but we switch the 1 and 4 and 1. And if we check this here, 3x times negative 1, negative 3x. 4 times x is plus 4x, giving us a positive x. Okay. Least common multiple. So if we look at both of these here, so the one on the left has a 3x plus 4. And the one on the right has it once. Since it appears once in both, we need it once in the least common multiple. We also have it appears once in the first one, but does not appear in the other. So we still need it once. Because if it appears at least once in both or in one, we need it at least once. Anything else we're missing? In our x minus 1. So the least common multiple for this here is 3x plus 4 times 3x minus 4 times x minus 1. That's it.
So what? So it's like 32 plus 15x, the last one, over what? I didn't get
Questions on this one here before we go back? What we're looking at today is complex fractions.
Sorry.
You're good? Complex rational expressions. Now, simplifying complex fractions, we have two ways to do it. One is to simplify the numerator and denominator into a single expression and then go through our process of dividing fractions. And the second method is using least common denominator. We're going to go through both methods. Now, I have a feeling I know which of the two methods y'all are going to want to do, but we're still going to do the first method first. Now, the first method states that we're going to try to get, and we need to get the numerator and denominator of this fraction as a single fraction. Well, luckily for us, the numerator, 5 over x plus 4, is a single fraction. But the denominator is not. So we need to get the denominator to be a single fraction. And to do that, well, we need to get their denominators to be the same so we can add them together. Well, our two denominators, one of them is x plus 4, the other is x. So the one on the left, our x plus 4, to get it to be the same, we're going to multiply top and bottom by x. And our 2 over x, we need to multiply top and bottom by x plus 4, so the denominators are the same. Now for the one on the left, we can multiply our 1 and x and get x over x times x plus 4 plus. We do the multiplication here. We're doing 2 times x plus 4. Well, 2 times x is 2x, and 2 times 4 is 8. And the denominator would be x times x plus 4. Questions on how we got to this point here. Well, the numerator is still one single expression, 5 over x plus 4. Now, since our denominators have the same denominator, x times x plus 4, we can add the numerator. So we'll be adding x and our 2x plus 8. Questions on how we got to this point here? We good up to this point. 5 over x plus 4. Now, the denominator, we do have some like terms. Our x plus 2x is 3x plus 8. In the denominator, we have x times x plus 4. Now we finally got it written as a fraction with one fraction on top and bottom. Now really fractions, like if we had 1/2, is the same as saying 1 divided by 2. So for us here, this is the same as saying 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. Well, if we're dividing like we're dividing two fractions, we keep the first one the same. We change it from division to multiplication and flip the second. Now at this point here, we can multiply the two together. And our 5 times our x times x plus 4 is 5x times x plus 4. Our denominator would become this here. Question on how we get to 5x times x plus 4 over x plus 4 times 3x plus 8. Is there anything in common on top and bottom? X plus 4, so we can simplify out our x plus 4 and x plus 4, which leaves what on top? 5x over 3x plus 8. Now we can't simplify our 5x and 3x because the 3x is connected with our 8. And 3x plus 8 does not factor any further because 3 and 8 do not have any like terms. So our final answer is 5x over 3x plus 8. Questions on this here? Not too bad of a method, a little bit tedious, yes? We ready for the next problem? All right, we're going to look at this problem here. Again. Same one, because there was how many methods that we can do this? 2. Now you can do it on top, because above it, we do have space. Least common denominator. Now they have, this whole thing has three denominators. I'm going to highlight them. We have our x plus 4. We have our x plus 4 and x. Yes. Now if we're finding the least common denominator, I'm going to list it out here. So x plus 4, x plus 4, and x. What's our first expression that's going to make x plus 4 and x plus 4 be the same? What's the first expression I can make both x plus 4 and x plus 4 be?
Equal?
X plus 4. Yeah. I mean, it's already the same, yes? We don't have to do anything to it. So for those, the least common denominator between x plus 4 and x plus 4, well, is x plus 4. Yes? So now we just need also our, what? X. So our least common denominator between these three expressions is x times x plus 4. Okay? We're good with how we got there. It's a little odd, especially with expressions, but that's our least common denominator. Now what we're going to do for the second method is I'm going to take that least common denominator and multiply the top and bottom of this fraction by x times x plus 4. So the whole numerator and the entire denominator, we're going to multiply by x times x plus 4. So we multiply the numerator with this. We're going to have 5 times x, which would be 5x times x plus 4 over its denominator, which is x plus 4. Questions on this here? Because when we multiply a number, say 6 over 7 times 3, where do we multiply the 3 by? 3 is multiplied by the numerator. Same is true here. Because even though it is as a fraction, we're multiplying the numerator with it, so it's still going to the top of that fraction. Now this is over. We're going to do the same thing with the denominator. So our x times x plus 4 is also going to multiply with our 1. Well, 1 times x is x times x plus 4 over x plus 4 plus. We're still do this with the 2. And again, we've been multiplying these monomials, the terms outside of parentheses, because they're just right next to each other. 2 times x is 2x times our x plus 4 over x. Questions on how we got to this here? What do we think? Easier or harder than what we did before? Question. Or why we're doing this, or how we did this? So why we'll get to. How we can address now. Because do we understand how we're able to multiply x, why this x times x plus 4 is multiplied with the 5, 1, and 2? Do we understand? Okay, that's fine. Because that means it's not so much a how, but a why we're doing this, and that's about to be addressed. Okay? If we look at the numerator, do we have anything in common in that fraction? Well, the x plus 4 and x plus 4 would simplify, yes? What do I have left in the numerator? Do I have any fractions left in the numerator?
No.
Let's look at the denominator in this first one. We have x plus 4 and x plus 4, leaving us with plus. Our last fraction, 2x times x plus 4 over x. What would simplify? Our x and, which leaves us with 2 times x plus 4, yes? Do we have any fractions left? No. That's why we multiplied by that x times x plus 4, that least common denominator, because when we did that, all of our fractions in the top and bottom simplified out. Yes? Now we just need to Simplify. 5x is already simplified. X is fine, but here we need to distribute the 2. 2 times x is? 2 times 4 is? 8. X plus 2x is? Questions on this here? Well, what did we get when we did it by the other method? Exact same thing, yes? So what do we think of this method here? A little bit nicer than method 1, yes? Because we're not having to try to get the numerator and denominator into a single fraction and then divide the 2. Let's look at another one. Least common denominator, we need to see what we need to multiply the top and bottom of this fraction by to get the fractions in the top and bottom of this fraction to simplify. X times x minus 2. Yes. Because the least common denominator of the denominators is x minus 2 and x, and we also have x. Questions on how we found the least common denominator? Now, we're going to multiply each of the numerators by this. So our top numerator, we're going to have 6 times x times x minus 2, which is over our x minus 2. Because that's our denominator there that we have to start with. Now in the bottom, the denominator, we're going to do our x minus 2 times 1, which is, well, x times x minus 2 over x minus 2, plus our other fraction in the denominator will be x, but we do have to multiply the x times x minus 2 with our 3. And with our monomials, these outside terms 3 and x, we will multiply them together. 3 times x would be 3x times x minus 2. Now, what simplifies out? On top we have x minus 2 and x minus 2, which does leave us with 6x. In the denominator, x minus 2 and x minus 2 leaving us with plus 3 times x minus 2. Now we need to distribute the 3. 3 times x is, and 3 times 2 is negative 6. X plus 3x is 4x minus 6. Questions on this so far? Now the question is, will the numerator factor? Because we do have a division of 2, because we can take it out of the denominator, because our 4x and 6x has the greatest common factor of 2. which will turn it into 2x minus 3, yes? And we can reduce that 6 over 2. 6 over 2 is 3. We have it in the numerator, and we still have our x. That's it. Questions on this here? Is this method becoming a little bit easier? And it's nice, this one, like the last one, we didn't have to do anything by method 1 for the numerator, but the denominator, we'd have to combine those to get 1. Then rewrite it as division, do our keep, change, flip, multiply, simplify. This here is a little bit quicker, a little bit easier. Yes? Are you ready for the next one? It is a little bit trickier, but not so much in the process, but finding the least common denominator. Because this time we have 4 numbers. 3, 6, 5, 10. Well, what would the least common denominator be for these here? Well, prime factorization, because we have 3, 6. It would indeed be 30. And if we did the breakdown, 6 is 2 and 3, 10 is 2 and 5. I'll go into 30, and it's the smallest number that all 3 will go into. Funny enough, 6 and 3's least common denominator is 6, because the first number we can turn both 6 and 3 into is 6, yes? What's the first number we can turn both 5 and 10 into? 10. So we're really looking at the least common denominator between 6 and 10. Because these two, least common denominator is 6. These two, it's 10. So we're really looking at 6 and 10. But if we look at all 4, prime factorization, we get this here. Now, 2 appears in 2 spots, yes? But since it only appears once in each of the spots for prime factorization, we only need it once. 3 appears in 2 spots, but in each spot it only appears once. So we only need it once. And lastly, 5 appears in 2 spots, but in each spot it only appears once. So for our prime factorization, leading towards the least common denominator, 2 times 3 times 5. Well, 2 times 3 is, times 5 is 30. So the first number, our least common denominator, least common multiple of 6, 3, 5, and 10 is 30. Which means for us here, we're going to multiply the top and bottom of this by 30 over 30. Still have 6, still have our 3, still have our 5. Now our 30 times our first x would be 30x. 30 times our x over 3, well 30 times x is 30x. 30 times our x over 5, well we're doing 30 times x, which is 30x. We're good with this so far? Yes? And I will tell you the last numerator is not 30x. 30 times 7 is 210. Now we need to simplify. 30x divided by 6. 30 divided by 6 is 5, and we have our x. Minus 30x divided by 3. 10x. 30x divided by 5. 6x. 210 divided by 10. 21. Now there's 2 things we can do. 1, 5x minus 10x is, yes, negative 5x. We need the negative. 6x minus 21, can we combine those? No. But can we simplify it? Is there a common factor between 6 and 21? 3, yes, we can factor it out. Since we couldn't combine it, but we can factor it, might as well just factor it. I mean, the other option is to rewrite it as negative 5x over 6x minus 21. Then factor the 3 out and rewrite it again with that. But not a whole lot of point in doing that. Now at this point, our 5 over 3 would reduce, yes? No. And that's as simplified as it gets. Now, even though factoring out the 3 did not help us simplify, we still need to do it. Just in case it did, just in case something did show up that did reduce, we want to factor it as far as possible. But since it didn't, this is our final answer. Questions on this here? Are you ready for the next one? What is our least common denominator? X. Because the only thing we have in the denominator of the numerator and denominator is just x, yes? Our 4 and 3 don't have a denominator other than 1, so there's nothing to simplify there. We're doing this to simplify fractions, yes?
But can I go see if it's solved fraction?
Yes.
Thank you. Sorry.
You're good.
Not just take the 2x.
We can't because of the minus and plus. Because they're stuck together. The 2 over x minus 4 is one term. They're stuck together. Yeah, otherwise, yes. Because if we could, that'd make this problem a whole lot easier. But because of that addition and subtraction, they're stuck together. Now, when we distribute this x times 2 over x is just 2x over x. Minus our x times 4 is 4x. We do the same thing with the denominator, 2 over x times x, 2x over x. Plus, x times 3 is 3x. X over x simplifies, giving us 2 minus 4x. The denominator, x and x simplify, giving us 2 plus. Because it's still just one term, yes? But what about 2 and 4x? The numerator. Yeah. Have a common factor of 2, which leaves us with 1 minus 2x. Is there a common factor with 2 and 3x? No. Because we can write the 2 plus 3x on the bottom without the parentheses. But if it does help as a reminder that those two are stuck together, we can still go on and list it. Now, we're going to finish this tomorrow. This is the assignment if you want to get started on it. We've done most of it. It's still the same process. It's just seeing them in different forms that we'll do.